Our sun, a blazing ball of plasma, began its life billions of years ago as an unassuming cloud of gas and dust. This molecular cloud, a cold and dark nursery for stars, held the seeds of our sun and its planetary system. Imagine this cloud, a swirling mass of hydrogen, helium, and traces of heavier elements. These elements, forged in the hearts of long-dead stars, held the potential for something incredible. The story of our sun is a tale of gravity, pressure, and cosmic alchemy, where simple ingredients combine under extraordinary conditions to ignite a star. In the grand tapestry of the universe, the birth of a star is common, yet each star, like our sun, emerges as a unique entity. As we delve deeper into the story of our sun, we'll uncover the secrets of its fiery heart and its profound impact on our planet. Join me as we embark on a journey to explore the epic saga of our sun, from its humble beginnings to its eventual fate. The birth of our sun was a violent and chaotic process, a cosmic maelstrom unfolding over millions of years. Our story begins within the cold, dense heart of a molecular cloud, harboring the raw materials for star formation. Disturbances, perhaps from a nearby supernova explosion, caused pockets of gas and dust within the cloud to collapse under their own gravity. As this material fell inward, it began to spin, flattening into a rotating disk with most of the mass concentrating at the center. This central region, called the protostar, continued to contract and heat up, its core becoming a crucible of intense pressure and temperature. The temperature at the core soared to millions of degrees Celsius. Finally, a critical threshold was reached, and hydrogen atoms began to fuse together, forming helium and releasing an incredible amount of energy. This fusion reaction marked the moment our sun was truly born, bursting forth as a radiant, life-giving star. The sun's formation was complete, setting the stage for the development of our solar system. The sun, our nearest star, is a giant ball of plasma, a seething ocean of charged particles held together by its own immense gravity. It's a dynamic and complex object, with a layered structure that drives its incredible energy output. At the very center of the sun lies its core, where the magic of nuclear fusion takes place. Here, hydrogen atoms are fused into helium, releasing the energy that powers the sun. Temperatures in the core reach a staggering 15 million degrees Celsius. Moving outward, we encounter the radiative zone, where energy generated in the core slowly makes its way outwards via radiation. Next comes the convective zone, where energy is transported through the bulk movement of plasma. Hot plasma rises from the radiative zone, cools near the surface, and then sinks back down, creating vast convection currents. Finally, we reach the sun's atmosphere, composed of the photosphere, the chromosphere, and the corona. The photosphere is the visible surface of the sun, while the corona extends millions of kilometers into space. The sun is far from static. It's a seething cauldron of activity. Its surface a dynamic landscape of magnetic fields and powerful explosions. Sunspots, those dark blemishes on the sun's photosphere, are a visible manifestation of the sun's intense magnetic activity. These regions appear darker because they are cooler than the surrounding plasma. Sunspots often appear in pairs, connected by looping magnetic field lines. Solar flares, sudden bursts of energy and radiation, occur when magnetic energy in the sun's atmosphere is suddenly released. Flares can last for minutes to hours and can be observed across the electromagnetic spectrum. Coronal mass ejections, or CMEs, are the most energetic eruptions on the sun, blasting billions of tons of solar material into space. These eruptions can interact with Earth's magnetic field, triggering geomagnetic storms that can disrupt communications and power grids. Understanding and predicting solar activity is crucial for mitigating these potential impacts. The sun's volatility reminds us of its immense power and influence on our planet. The sun, our very own star, is a source of endless fascination. It's a celestial object of immense scale and power, yet it's also intimately connected to our lives here on Earth. The sun accounts for 99.86% of the total mass of our solar system. It's a giant ball of plasma, a state of matter where electrons are stripped from atoms, creating a sea of charged particles. While light travels at an astonishing speed, it still takes about 8 minutes for sunlight to reach Earth. The sun generates sound waves due to the constant churning and convection within its interior. The sun's energy output varies slightly over an 11-year cycle, known as the solar cycle. This cycle is linked to the number of sunspots, which wax and wane over the same period. These are just a few of the many fascinating facts about our sun, a star that continues to captivate humanity. The sun, our constant companion, will not shine forever. Like all stars, it has a finite lifespan, and its eventual fate is a dramatic transformation. Currently, our sun is in the prime of its life, comfortably fusing hydrogen into helium in its core. In about 5 billion years, the sun will exhaust the hydrogen fuel in its core. The core will begin to contract, causing its temperature and pressure to soar. The sun will expand dramatically, ballooning into a red giant star, possibly engulfing Earth. As the sun continues to expand, its outer layers will drift off into space, forming a planetary nebula. At the center of this nebula, the sun's core will remain, a dense, hot ember known as a white dwarf. This stellar remnant will slowly cool over billions of years, eventually fading into obscurity. Our once mighty sun will have reached the end of its stellar journey. The sun story is not just a tale of stellar evolution. It's a story intimately intertwined with our own. For billions of years, our star has been the lifeblood of our planet, providing the energy that drives our climate and fuels our ecosystems. From the moment the first photosynthetic organisms emerged, our planet has danced to the rhythm of the sun's cycles. The sun's energy drives our weather patterns and underpins the intricate web of life on Earth. As we've explored the sun's life cycle, we've seen that our star will not last forever. Yet even in its death throes, the sun will leave behind a legacy, a planetary nebula seeding the interstellar medium with elements for new stars and planets. Understanding the sun is crucial for the future of humanity. By harnessing its power through solar energy technologies, we can transition away from fossil fuels and create a more sustainable future. The sun, which has sustained us for millennia, holds the key to a brighter future. Embracing its potential is essential for the well-being of future generations.